And we're going to establish what we're going to need to label these two guys, which is our old familiar friend, the quadratic formula. Now, before we get to the quadratic formula, okay, what skill do we have that allows us to get to the quadratic formula? How do we get there? Yep. Completing the square, very good. So let's consider just any old quadratic. We'll stop thinking about this for a little bit. And let's think about this. Okay, so let's go. Okay, now I've picked a quadratic. This is always the quadratic I pick because everyone can immediately see, because we've been dealing with these for long enough, everyone can see the roots of this quadratic, right? And therefore, by implication, the factors. If you can't remember what the difference between those are, we'll get to it in a second, right? So really quickly, how would you just factor that directly? What would you write down?
X plus 1, X plus 5.
What?
Try again. That's what I meant to say. Okay, so
I was testing everyone.
well done. You succeeded. Okay, now it's all right. It's the morning. We're looking for a pair of numbers. Add to this, multiply to that, and that's your pair, right? Okay, so that's one technique, and that's fine. That's because these numbers are neat. How would we complete the square if the numbers were not neat? I want to use the same quadratic because we know what the answers are. Yep.
Move the 6 to the right hand side.
Okay, let's give this a go. So x squared plus 5x equals negative 6.
Then b divided by 2 and square it and add it to each side.
Okay, so we've got this number here. This is b. Yeah, that's our second coefficient there, coefficient of x. So I'm going to halve it, square it. Let me say it again. Halve it, square it. Halve it, square it. That's all you have to do. That's all there is to the quadratic formula. Okay, I'm going to halve it, which gives me 2.5. And when you square 2.5, what do you get? You get 6.25, right? 6.25. If I've added it there, I'd better add it here. So far, so good? Yeah? Okay. Now, the reason why I did this, why did I halve and square? What was the point of halving and squaring? This guy over here is a perfect square. No need to write this part down, but just to remember, right? If you have something like this, what should I choose? I'll choose. No, I want a letter. I'll put it C. Okay. If it's a perfect square, then when you expand, you're going to get 2cx plus c squared. Okay. So I've got this piece here. This is the piece that I have, right? So to go from this to this, you halve it, that gives you c, and then you square it, and that gives you c squared. So I've halved it and then squared it. So now that's the perfect square, and I can climb back up here to something all squared. What's the something? 512. It's the halved part, right? It's just the c. Okay, so 5/2. What have I got over here? It's just a quarter. Okay, so this is good. This is better. Right, I've made some progress. I have something factorized, but what do I do now? Okay, I'm going to take the square root of both sides because I just want x, right? So I take it over here, which means on this side,
Plus minus half.
good, because it's squared. I don't actually have x equals the square root of something, which is just one value, right? So I actually have this. So far, so good. Okay. So now I'm going to bring this guy over here. Yep. So now I have minus 5/2 minus a half. That'll give me my left one. That's minus 6/2, which is negative 3. Or, because it can't be both of these things at the same time, minus 5/2 plus a half, which is minus 4/2, which is negative 2. Okay, so what have I done? I've done two things. These guys here, see these guys? X plus 3 and x plus 2. These are my factors. These are my factors. Just like when you say 21 is 3 times 7. This is this times this, right? So this is a product and these are the factors. These are not factors, right? Because this is not minus 3 times minus 2, right? These are not factors. In fact, they are, you can think of them a couple of different ways. You can call them roots, because what they would correspond to is where they collide at these 2 points. Alternatively, a bit more of a technical way to say it is they are zeros. which is a bit confusing when you say to someone, oh yeah, my 0 is 2. It's like, I don't know, my 0 is 0. What that means is, if you put either of these in to here, you get 0, right? It's what makes the function 0. In other words, they're the solutions for this because that's what I want, equals 0. Right? Okay, so that was completing the square. We didn't need to because it was simple. But now, I need the space over here. Let's take a rather more difficult version. Okay, now, I'm going to see if you remember this. I'll give you a minute to think about it. We walked through how to complete the square in a simple numerical example. This is neither simple nor numerical. It's a bit complicated and it's algebraic. Give it a shot and see if you can get what you need to at the end.